5 factorial is equal to 5 times 4 times 3 times 2 times 1. So let's say if you have another one that says 7 factorial. So whatever you get becomes the value of what factorial is all about. What are the parameters that you need to pass? Obviously is an integer. Then you also return an integer. Okay, so let's go. We're trying to get the factorial and we're trying to repeat the same thing. From this, you have to do a loop. So when you run this, even though it's still going to give you factorial none, we are focused on this so that to start to debug or start to fix our results. That's the idea where we are printing and to be making adjustments to say, oh, okay, we don't need 0 and 1. Remember, I said we don't need 0 and 1. If you anything you multiply between this will still give you your results. Your 0 and 1 does not give you anything special. So how do you eliminate 0 and 1 is by starting from 2. So when you start your counting from 2, you get to 2, 3, 4. But what about 5? How do you get to count 5? We can then do +1 here, because here you are extending the reach of where you want to count to. So you can do +1. And the reason why that is because of the 5 here. What if you do 7? Of course, because we've done 7 n plus 1 here, it will extend to 7. And that's why we're passing a variable, so that we're not fixed to a number. And then you can see it also gets to 7 because we've added our +1 there. So let's stick to 5 and continue what we want to do. I don't know if this is the right time for me to include this, but let me just throw it out to you guys. Let me introduce it. It's called recursive. Recursive is a method in which a function will call itself. So let me show you how that works. So we want to do a function that will call itself. And when you are doing this method, you must make sure that the function will end at some point. Because if you call yourself forever, you will get what they call Stack Overflow. And the reason why I wanted to show you this method is because you guys will not think of using this method. And it was an opportunity for me to demo this particular method to you guys. So here we want to enter a value. And what I want to do is a way to return itself. Remember the definition. The definition is that it always returns itself. And then I can pass, a value to it. Don't worry, we're going to talk about how, it will not run forever. So what I want to do here is I want to print the current value that I have. So here is I have n, print n. So if I run this code will run forever. Look at it very well, guys. If I call recursive and I pass 10 to it, it will print 10. It will run this, it will run itself. Do you see what's going on? I'm calling myself. That's what is happening here. But you need to find a way to make sure that this guy terminates, itself. So we can have a condition here to terminate what we are doing. To say if n is equal to 0, right? Then terminate. So how do you terminate that? Is by saying return. So whenever you write a function and you say return, it ends the function. Now, what that means is that we then need to find a way to not keep passing the same value. And the way to make sure that we adjust this value is to say something like -1. So what that means is if we pass 10 to this place, the system will run and print out 10. And it will call this function and it will do 10 minus 1. It will go back and continue until when 10 is 0, then we are good to go. We'll stop. So let's, call this recursive function. So I'm going to comment out this one. So we're calling this guy like this function, and then I remove this guy. Okay, let's run it. Fingers crossed. So I run this guy now. So do you see what happened? It did 5, 4, 3, 2, 1. When it calls it the first time, it is 5, right? It goes and prints 5, and then it does 5 minus 1, and it go and call it, then becomes 4. It prints 4. It does 4 minus 1. It becomes 3. It calls it. That is what I just did here, guys. And this is the method I wanted to use to do factorial. This is the method. This is a very crazy method, guys. And the reason why I wanted to use this method is because I know you guys will have done the normal method. If I do this guy like this, I can do something like this and do my n minus 1. So if I run this, you can see, guys. So you can see the current n. So you can know the previous n by doing something like this. And what this allows you to do is that it shows you, oh, 5 times 4, 4 times 3, 3 times 2, 2 times 1. Of course, when you get to 0, you can say that you should not times by it. So here you can say, because here already contain n minus 1. So whatever result that you have at n minus 1 is your previous result. So your current result is your n. So you can say n times your previous result will give you what we are looking for. So if we run this now, it will give us, it should give us our answer. So if you run this, you have error. Oh, okay, this is where the issue is coming from. So let me explain what's going on, guys. Remember that at some point, when the last one occurs, it's gonna give us null. You can see that we're not returning anything here. We're not returning anything here, so that's the problem. So it's comparing the one that has value with the one that does not have value, which is non-type. This is, I didn't return anything here, guys. So I'm supposed to return something at least. So whenever it is 0, 1 is always safe for us to return. 1 is always a safe result for us to return. So if you call this one again now, so you should have something like this. So it's not doing the work for us very well. Of course, if you return 0, you get 0. Everything, it will spoil everything for you. You have 0 because once you are multiplying everything, you multiply by 0, it will give you 0. So if you look at it very well now and you run through it, you will see that 5 multiplied by this, multiplied by this, multiplied by, once you get to 0, it will just return 1. So it will not give you any issue. So the second method is this. This is called the loop method. In this method, you are looping. You're using loop, power of loop, to check, because you know you have to go through 1 till the end of what it is you want to do. So the next thing you want to do here is a way for you to be able to multiply the current value and the previous value. That's one of the things you need to be able to do here. We need to be able to have something we're using to times. And what I want to use to times is results. A variable to hold our value will be timesing with. So we'll call that result and we give it a value of 1 because it's going to be multiplying the previous values. So you can't give it 0. Anything multiplied by 0 is also 0. So we give it 1. 1 multiplied by anything will give it itself. So we have that one set up there. The next part is for you to be able to do results is equal to result times I. So this is what, will give us what our result is. So if you run this, you should have the same 120. So this is factorial normal using loop, and this is factorial using recursive. So they all give you the same thing. So if I do, factorial is crazy. If you do factorial of 10, I think it's still close. We still get sizable number. So let's do factorial of 15. You don't want to do factorial of big number. So let's do 16. Factorial is crazy. Let's do 17. I don't want the number to go out of scale. Let's do 20. So you can see big numbers. Let's do 50. So that's 50, guys. 25. So by the way, loop is always faster. You can see crazy number. If you do factorial of 100, this is what you get. Like who does this math for you? Factorial of 1000, gonna go a wire. Aha, good. That's a good one. So this error, this error is caught automatically. You've exceeded the maximum number of time you can call a particular function. This one complex more. Write a button quiz program. So I will give you guys hints. A list or tuple or dictionary, anyone you want to use, that holds question and answer, right? So you can have question like so that says so this is the question is saved in a dictionary where you now have the first item, which is question 1, and then it has these values. One of the value, all the values are the answers, which one of them has to be the answer to the question. I mean, in this case, there's no multiple answer, just one correct answer. So the one that is correct has to be true from the list. So if the user pick that option, that means they are correct. So let's just make it 3 options for now. And you can make this dynamic. So this is question 1. Then question 2 is going to go in that same line. Question 2 is also going to repeat the same approach of having different options. This is going to be option 1. Then you can say the option 1 value is true. Then you can say option 2, and you can have it being false. And you can just, stop there, or you can be as dynamic as you want. So this is just for 2 questions, guys. So you should be able to loop through these questions and say, hey, question 1, who is the governor of Lagos? Right? And the options should be there, displayed to you. And you should be able to choose from the option and say, oh, the answer is 1. And at the end, the system should say you are correct or not. And you can have as many questions as you want. You also need to be able to maintain a score for the person that is taking that quiz. So if you fail a particular question, it should score you down. You're going to take, maybe if you are taking 10 questions, and it should monitor how well you perform. So if you pass anyone, it should give you +1 until you finish. So if you have 10, the system should be able to say, hey, you did great. You got 10/10. Or based on the result that you get, it should always announce your score.